The Big Bang only gave us elements up to beryllium. It didn't have the capacity to form any higher elements. Where all the higher elements than beryllium occurred were in suns. Now, what happens for the formation of carbon, you have the triple alpha process, where there's enough energy and enough gravity for the heliums to just slam and mold into each other and fuse carbon. It has enough energy and it has enough gravity to get past the nuclear barrier for the formation of carbon. Formation of oxygen, you have the carbon and the helium. They mold into each other through gravity and energy, of course. And the higher elements than oxygen, carbon, came from these two right here. The second process in the formation of higher mass elements is the carbon fusing process. In these three examples, the carbon forms highly excited 24 magnesium atoms, leading to decay. It's not so much the carbon fusing in its element formation as it is how the elements formed decay. We have the alpha decay, which produces the neon nucleus and the helium nucleus. We have the 23 sodium isotope and the formation of the hydrogen atom. We have the 23 magnesium isotope and the formation of a neutron. The third process in the formation of higher mass elements is the oxygen fusing process. We have the formation of oxygen from the fusion of carbon and helium, and we have the three examples of the oxygen fusing and what elements they produce, which are obviously also dependent on how the element produced from the fusion decays and what element is formed. With the alpha decay, we get silicon. With the first beta decay, we get an isotope of phosphorus. The second beta decay, we get the formation of sulfur, showing the importance on how the element that is formed from the fusion is dependent on how it decays. After the oxygen process, there's the alpha process, where the silicon formed from the oxygen fusing fuses with helium to form sulfur. Sulfur fuses with helium to form argon. Argon fuses with helium to form calcium. Calcium fuses with helium to form titanium. Titanium fuses with helium to form chromium. Chromium fuses with helium to form iron. Iron fuses with helium to form nickel. Due to the increasing of the Coulombic force of the nuclei, after this, it cannot go any further with this process. It can't produce any higher elements from this process. Therefore, there's another process needed, the S process. The formation of elements higher than nickel occur when a star becomes an old red giant through the S process, where neutrons slowly enter the nucleus. When too many neutrons are in a nucleus, the neutrons decay into a proton and an electron, creating proton-rich elements all the way up to bismuth. Elements higher than bismuth, all the way to uranium, are formed by the R process, where neutrons rapidly enter the nuclei from the explosion of a supernova. The rapid process is where the neutrons, of course, go into the nuclei very quickly, and it doesn't give it enough time to disintegrate. Since our planet is a collection of element particles produced by a supernova, we have all the naturally occurring elements all the way up to uranium, which is the main component in the uranium oxide mineral, uraninite. Uraninite is the mineral from which Marie Curie discovered and isolated radium and polonium. Madame Curie noticed that uraninite produced higher levels of radioactivity than pure uranium did, and hypothesized that a new element was in uraninite with more radioactivity. She formed radium chloride and noticed it had alkali earth metal properties, reacting with two chlorine molecules through stoichiometric balance analysis. To make sure it wasn't barium, Madame Curie performed quantitative analysis to determine radium's atomic mass. The mole is the representation of atomic and molecular mass in grams. Here are the quantitative analysis calculations used by Marie Curie to determine the atomic mass of radium. By using the amount of silver chloride formed by the reaction between radium chloride and silver nitrate, we can arrive at the atomic mass of radium. First, we put the gram amount of silver chloride into mole form. To do this, we divide the grams of the formed silver chloride by the silver chloride mole. Here's how much silver chloride was formed in the reaction, 0.0899 grams. And here's the mole of silver chloride, 143.2 grams per mole. We divide the gram amount formed by the mole, and we arrive at 6.2081 times 10 to the power of negative 4 moles of silver chloride formed in the solution. Since the mole ratio of silver chloride is 1 silver mole for every 1 chlorine mole, the chlorine mole will be the same amount as the silver chloride formed. Since the ratio of radium chloride is 1 radium mole for every 2 chlorine mole, we divide the mole amount 6.2081 times 10 to the power of negative 4 moles. We divide that by 2, and we achieve 3.10405 times 10 to the power of negative 4 moles of radium chloride in the solution. Since the gram is inversely proportional to the mole, we divide the gram amount of radium chloride by the calculated moles of radium chloride in the solution and arrive at the radium chloride molecular mole, 296.1292. Here is the amount of radium chloride, 0.09192 grams. We divide that by the calculated mole of radium chloride in the solution, 3.10405 times 10 to the power of negative 4 moles, and we arrive at 296.1292 grams per mole of radium chloride. To get the atomic mass, we subtract 296.1292 by the Cl2 molecular mass, 70.8, and arrive at 225.329. The calculated atomic mass of radium. It is wrong, but it is extremely close. The reason it's wrong is because radium is constantly decaying, and it's very hard to calculate its atomic mass through these means, but it is extremely close. There was another element that is in the Uraninite mineral. It was helium. It's helium. There's another element that can be found in the Uraninite mineral. Helium. Sir William Ramsay noticed that there was a gas that was highly unreactive, extremely unreactive. It would not react at all. And he isolated it and did spectral identification on it. He noticed that it had the exact same spectral lines that was reported by Lockyer and Janssen from the element helium that they discovered in the sun, confirming the existence of helium. We are going to be talking about the utilization of minerals by industrial companies